Turn to page 7 in your notebook, please. Alright, on your homework page, on page 7, let's talk about what we've learned so far. We've learned how to write the first 4 terms of each sequence whose given term is whose general term is given. This is like the what of the sequence. The starts with R and has 3 letters after it. It's like the what. The rule, isn't it? Starts with R, U-L-E. It's the rule of the sequence, okay? Alright, like, so if I'm asking you for the, okay, how do you denote, backtrack around, how do you denote the first term of the sequence? A sub what? How do you do the second term? A sub 2. Those are the numbers that you're putting into this rule, and your output is what you see in the sequence. Does that make sense? We're thinking of sequences in terms of function now. When you plug 1, 2, 3, those are your input values, and they come out as output. So you can really graph sequences. Okay? Now, what did you have up here? 1 through what? 1 through, I thought it was 1 through 5. Check your homework.
First 4 terms.
I know, I'm talking about what numbers did you have to do for homework. 1 through 5. Check your answers. I'm going to come around and look at your homework in just a second. Here are your answers here, and here's your answers there. Yes, sir. Can you see the board better? And I just moved that much. I'm on move 5 in a minute. Are we good on number 1 and 3? Let's look at number 5. It's a more complicated one. The first term of 5 is 1. A sub 1 is 1. A sub 2 is negative 1/3. A sub 3 is 1/7. A sub 4 is negative 1/15. Are there any questions of how I substitute something in there for that problem? So no questions on 1, 3, and 5? Okay. The second thing that we looked at was factorial expressions. So let's check 7 and 9. 17 factorial over 15 factorial. The definition of factorial is you start with a number and go all the way down to 1. However, I stopped at 15 right here because couldn't I cancel those out? So 17 times 16 is 272 is my answer. Number 9, n plus 2 factorial. You take 1 off of it, n plus 2. If I take 1 off 2, I got n plus 1, don't I? I take 1 off that, I have n factorial. I stop there, and these n factorials cancel out. I'm left with n plus 2 times n plus 1, which multiplies out to give you n squared plus 3n plus 2. This is what your quiz is going to be on Thursday. If you were absent yesterday, you need to watch the video from yesterday. Then the third learning target, we dealt with summations. Summations. This is summation symbol. It's called sigma notation. Summation comes from the word sum. So you're dealing with a lot of sums. You see I have a lot of pluses here. You want to know the sum of the expression from where n equals 1 to n equals 6. So I plug in 5 times 6 plus 5 times 5 plus 5 times 4 plus 5 times 3 plus 5 times 2 plus 5 times 1, and I come up to the answer of 105. This variable right here should match this variable. That's why on number 13, yesterday I had like a 2i squared. This should match that variable, okay? So if you ever see a misprint, there's one like that in your homework tonight, and I got it over there on the board to change it because there's another I where it should be an N on number 12. So go on and look at your homework on number 12 right now. You need to change it to 7N, not 7I. Number 12 is 7N, not 7I. Is there 7I? So what is it? Alright, look at number 13, 2n squared. I want to know what's going on from 1 to 4. So I plug 4n, then 3, then 2, then 1. 4 squared is 16, times 2 is 32. And then 3 squared is 9, times 2 is 18. 2 squared is 4 times 2. 1 squared is 4, and then it comes up to 60. Are there any questions on how to handle summations? Okay. Like I said, I am videoing this if you need a bunch of So let's look at 15 and 17. They're a little bit more complicated. Here's your expression. I want to know what's going on from 0 to 4. So I plug 4 in. Negative 1 to the 4th power is a negative raised to an even. That's going to be a positive 1. 4 factorial is 4 times 3 times 2 times 1, which is 24, I mean. Negative 1 cubed, that is negative 1 times negative 1 times negative 1 is negative 1. 3 factorial is 6. Negative 1 squared is negative 1 times negative 1, which is positive 1. 2 factorial is 2 times 1. Negative 1 to the first is negative 1. 1 factorial is just 1. Remember, 1 factorial and 0 factorial is both 1. Okay? Now, I would put all those fractions in the calculator and add, and you get negative 5/8. Negative 5/8. This was a good one right here, number 17. N factorial over n minus 1 factorial. I want to know what's going on from 1 to 5. 1 to 5. I plug 5 in. Now let's look at it. If I got 5 factorial over 4 factorial, I would write 5 times 4 and stop because those 4's can cancel out here. So really, what is all this going to equal down here? 5 plus what? Plus what? Plus what? Plus what? 1. Because right here, guys, if I got 5 times 4 factorial, what does that cancel out and leave you with just 5? And here you got 4 times 3 factorial. That cancels out, just leaves you 4. That's how I got these simple numbers here. Does that make sense? This is weird. 1 factorial is 1. 0 factorial is 1. 1 divided by 1 is just 1. That's the only weird part of that. Does that make sense? Yes, Luke?
So on 15, do you ignore the n equals 0?
Yeah.
Oh, did I not do the 0? Yep, I know you should have done 0. I'm sorry. So I'll go back up here. Anything raised to 0 is 1. 1 over 1 is plus 1. So I need to add 1 to that, and you get 3/8. Is that what y'all got? I'm sorry about that. Yeah. I should have a plus 1 in there. Thank you for catching that. Alright, are there any questions on those 3 learning targets? So far, if I give you the rule, or the general term, it's called general term, but it's just the rule, could you tell me the first 4 terms? Okay, by plugging in 1, 2, 3, 4. So do you understand what a factorial expression is now? That's the exclamation point. That's the second learning target we dealt with in this unit. And third is how to use summation. Simple. Are we good? Okay. Alright, today let's look at our first learning target. KJ, can you read that first one for us, please?
I can write the first 6 terms of an arithmetic.
Arithmetic
sequence.
Arithmetic, very good. I can write the first 6 terms of an arithmetic sequence. Arithmetic sequence. Alright. We talked a little bit about arithmetic. In arithmetic, what are you doing? Adding. You either add a positive, negative number, fraction, whatever. So turn to page 3 in your notebook. Page 3. This is real easy. Some of you, this is a great test grade to start off your 4th 9 weeks with. This unit is a lot easier than the unit we're about to go to. So you need to bank this test and learn this. Alright, so definition. An arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. An arithmetic sequence is a sequence in which each term after the first differs from the preceding term by a constant amount. This difference between consecutive terms is called the common difference of the sequence. Okay? That's going to make sense in just a minute why it's called common difference. You're adding, but they call it common difference. And it's going to make sense in just a minute. So the first thing you want to do is write the first 6 terms of each arithmetic sequence. So guys, what I do is I'd write 6 blanks. Don't they give you the first term? A sub 1 is the first term, isn't it? So I put 4 in that first blank. Because A sub 1 equals 4. That's the first term. And you want the first 6 terms. D stands for common difference. That is what you're adding to each term. What's 4 plus negative 7? Negative 3. Negative 3 plus negative 7? Everyone, negative 10 plus negative 7 is? Keep going. And then what? Those are your first 6 terms. You're adding a negative 7. That's why it's arithmetic, but you're adding. Now this is why it's called common difference. If you took this second term, watch this. Negative 3 minus 4 gives you what? Negative 3 minus 4 is what? Isn't that your common difference? That's why it's called common difference, is because if you were to find it, you would subtract any of this one, any of these. Like here, I subtract this one minus this. You could do this minus this, but you cannot subtract this and this. You can't skip a term, okay? It has to be right next to each other. Because what's the inverse operation of addition? Subtraction. That's known as difference. Does that make sense? Does it, Mary Catherine? All right, let's look at number 2. What's the first term of the arithmetic sequence? Negative 6. And I'm going to add what to it? So negative 6 plus 5 is negative 1. Negative 1 plus 5 is 4. 4 plus 5 is 9. 14, 19. I want you to do number 3 on your own right now. Use your calculator. onion rings didn't come in today, so there's no onion rings. We just got email. You get 3 chips. Whatever chips I get. The onion rings are coming later today, so they would pop back up sometime. All right. What did you get? What's the first term? 3 what?
3/4.
What's the second term? Everybody should be looking at me and responding. Second term is what?
7/4.
No, let's go back. We didn't have. First term is 3/4. Second term is?
5/4.
Third term is?
7/4.
Fourth term is? Fifth term is? And the final. Are we good on that one? Okay, can we move on? All right, our second learning target now is I can find an indicated term of an arithmetic sequence. I'm about to show you a formula that can be used to find it. Let's say I wanted you to tell me the 120th term of that sequence. Instead of right down to 120, I can just show you a formula. That's what we're doing today. Well, if I ask you to find the 81st term, it is a formula. So that's what you get to use an index card because you're going to have a lot of formulas. So the index card is what you need to write this formula on. So this formula right here tells you indicated term, any given term of an arithmetic sequence. So you need to write that down. A sub n equals a sub 1 plus n minus 1 times d. That's the general term of an arithmetic sequence. Okay, let's make your way.
Yep.
Write that down on your index card. Alright, so on number 4, how do we use this? This is find the 8th term. I want to find the 8th term of this arithmetic sequence when given the first term and the common difference. Okay, you see this a sub n right here? That's the one you're looking for. So I'm going to replace that with a sub 8 equals. What is a sub 1? 4. I plugged that in for that. Plus. Now, do you see how this n and this n is right here? If I let this be a sub 8 right here, the n is what value? What's going to be in the value of that? 8. Do you see that? Your d is negative 7. Order of operations. 8 minus 1 is 7. 7 times negative 7 is negative 49. Negative 49 plus 4 is negative 45. That is your 8th term of this sequence. That's all you do. Number 5. What term do I want to find on number 5? I want to find the what term? 9th term. Let's make sure we set it up. A sub 9 equals, what's my first term? 6 plus, what will go in for n on this one? 9. 9 minus 1, and your common difference is 5. A sub 9 is 46. Bless you. Number 6. Find A sub 12. When A sub 1 equals negative 8 and D equals negative 2. So A sub 12 equals, your first term is negative 8 plus 12 minus 1 times negative 2. 12 minus 1 is 11. Negative 8 plus negative 22 is negative 30. This is pretty easy, isn't it? Y'all like this? That's the formula you find for finding any term in this sequence if it's arithmetic. Geometry is not something different. Let's turn it over. We're going to get further than what I thought. Now there's another formula. If I ask you to find the sum of the first 15 terms, or find the sum of the first 50 terms of an arithmetic sequence, this is what you use. Sum. And the way I remember that, if I'm asking you to find the sum, you see that S right there? You know to use that for the sum formula for arithmetic. So write that down on your own index card. You're going to have 4 formulas on this next test. The one that was just on the previous page. The one that we're using. Oh, that's the a general term of an arithmetic. That formula you just wrote was, however you want to remember it, that's to give you any given term for arithmetic. This is the sum of an arithmetic. Yes. So here, they start off, they say, find the sum of the first 15 terms of the arithmetic sequence 3, 6, 9, 12, dot, 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 dot. They don't give you all 15. So you're going to use this formula to help find it. So let's look here. So on number 8, I'm going to put sum, I'm going to put a little 15 because that's what you want to find, the sum of the 15 terms. Equals, if I put 15 here, what's going in for this n up here? 15. Aren't those the same thing over in this formula? So I'm going to put 15 over 2. Parentheses. What is a sub 1 over here? What's the first term? 3. Plus a sub 15. I got everything I need, but I don't know a sub 15, do I? How can I find a sub 15? Go back and use that formula we just learned. So now I'm going to come to the side. A sub 15 equals a sub 1 is 3 plus 15 minus 1. Now, in this formula, guys, we have a D, the common difference. How could I find my common difference here? 6 minus 3, which is what? 3. I found my D to be equal to 3. They don't tell you everything in these. You got to understand the vocabulary. So a sub 15 equals 3 plus 14 times 3. 3 plus 42, which is 45. So that's what I'm going to plug in. S sub 15 equals 15 over 2. 3 plus 45. When you multiply that out, that gives you 120. That means if you were to take the 15 terms of that sequence and add them together, you will get a sum of 120. This is just knowing formulas and know how to use them. Okay, we're going to do one more. Okay, say 15. Did anybody else get something different?
Yeah, I got 360.
Okay, it should be 360, and I'm sorry. Yeah, it's 360. 360. Okay, let's look at 9. I want to find the sum of the first what? 100, so I'll put S sub what? 100 equals 100 divided by 2. A sub 1 is 1. Now I want A sub 100. Because you're going out to whatever your sum is, that's the last term, A sub 100. And I need to put that there because they're all the same variable. So if I put 100 here, I'm going to put 100 here, and I'm going to put 100 here. Does everybody understand that? Does that make sense? Look at me, y'all. Does that make sense? Okay, now how will I find A to the 100? I got to go to the what? Side. A sub 100 equals, using my formula right here, A sub 1 is 1 plus 100 minus 1. How would I find my common difference? 3 minus 1 is 2. So I will put a 2 there. So A sub 100 equals 1 plus 99 times 2. And that comes out to what? 199. Now I take that value and I plug it back in here. The sum of 100 equals 100 divided by 2, 1 plus 199. That's 50 times 200, which is 10,000. So you would take all the first 100 terms and add them up. That will give you a grand total of 10,000. How do you feel on this lesson? I need a hand signal. Tell me something, yay or nay. Okay, we're not leaving until I see everybody's hand signal. I don't care how long we stay. So what you need to do tonight is practice your homework and learn what these things mean and when do you use the formulas, okay? So your homework reviews previous stuff. It is page 7, 8 through 16 even, and then 19 through 31 odd. 8 through 16 even, that's reviews yesterday, and then 19 through 31 odd. It's like 12, 13 questions. Have a great day. We're going on to geometric tomorrow. Bye, Doug. Yeah, you were asking what seniors to put. Okay. So, like, I nominate every senior in my class, first and second period. And senior superlative is voted on teachers. After you nominate, you're supposed to vote on the students that you believe are like best all around and everything, like extracurricular, academic, the best, yeah. And your teachers, like everyone, all seniors in there nominated you, and then every teacher nominates, and then it goes, and then whoever gets the most votes out of the entire 150 teachers gets the top. Yeah.
I didn't know that either. I didn't know what that was.
And all you do is take a picture and put it in your book.
Dude. Come on, bro.
You did? Yeah. So Miss Elliott told me.
What now?
I got chosen. They announced it over the conference morning. I was like one of the nominated.
You were nominated because I nominated you.
This is all I did. I threw 85.
Yeah, it was.
You were throwing people, my dude. For 3 hours.